So BIM, the most important thing with BIM to learn is the eye, the information that we put in. The rest of it's graphical. You know, we can make a picture of anything that we want. So what we look at is really looking towards the information in it and how that's delivered and what those outcomes are. So we've already said that we've got a big problem. You know, how do we get into it? It's a massive problem. It's part of our industry. And where do you even start attacking a problem like that? Well, I think the first thing to do is recognize that we are in a legacy industry. You know, it's long past its sell-by date. When we have an industry where we only see 1% of productivity gains in each year in the last 20 years, we know we have a problem. In essence, what's really changed here, while the rest of the world's moved, this is the elephant in the room. It's gone nowhere. Why? Communication. Well, communication with architectural offices and engineers and the constructors are pretty back to front. A lot of architectural offices I go to, I still see them using servers in the back office or Dropbox, and that's high tech for them. Those are the advanced ones, so it's rather worrying. So delivery of information in the same way is still 2D. So instead of them posting you reams of documents, now you get them by email, which is nice, but it's still 2D and it still is very fragmented. You only get a portion of the information. And it's low fidelity and it's uncoordinated. So if you get a set of engineering drawings, nobody believes it's their responsibility to necessarily coordinate it with the architectural drawing or the MEP ones. It's left to the contractor who then slows down the project while everything is resolved. And so if you enter a project which is unlike the project that Chris did, where everything is worked out in advance, you will kind of just have a bumpy road until the end. You kind of strap in and you go, well, I've started now, I've got to get to the end. So, in the same way that everything else is fairly ad hoc in the AEC, so is procurement of construction goods and labour. They're difficult to trace, they're time consuming, and they're prone to error. For the same reasons, you have 2D information coming fairly late, and you have a procurement guy actually picking up the phone, trying to get things to the site in time. So, you know, where it comes from, is it sustainable? Those type of things go out the window pretty quickly. So, you've got outdated software, dysfunctional communication, and a lot of waste as a result. So, our quest is to make waste-free working a sector-wide norm. And so we have working models to do this, and we have a slightly different approach. We look at BIM in a different way. We look at it in taking it down to the very last nut and bolt, hinge, doorknob, pane, understanding everything that's in your building through a virtual model. And we call it hypergranular because unless you really get it down to every single nut and bolt, you can't put it on chain. And as soon as you put it on chain, it's traceable, you can figure out where everything's come from, who built it, how it was built, how much carbon was in it, and you can string this together into a whole. So this is what we have at the moment, what I'd like to call lo-fi BIM, which is people using Revit, making a very basic model, and making a lot of CGIs of that for the client to tell them what they're going to get. You know, painting the pretty picture. And there's a problem with that. So, when you have a rough 3D model, not very accurate, you take it backwards to 2D. Instead of using a 3D model to build a 3D building, you then take that down into a series of 2D plans and sections and elevations. Again, that's really going backwards. It's really like giving up your bank card and going into a bank and having a scribe in the background write up your money order. So a lot of that, when you're going 3D to 2D, a lot of it gets lost in translations. And the guys at site trying to build it wrong, and you have this unvirtuous circuit, if you like, cycle. So that's what we've been through. So 3D to 3D, 3D to 2D connects. 3D is what we're doing today. And what we're trying to do, or what we look at tomorrow, is doing 3D to 3D. So you have a model, you take that model, it becomes incredibly easy for the workman to know what they're doing. And today we can put models in everyone's phone or everyone's iPad, so it's entirely accessible. So, what will a hypergranular model look like? This is a model actually created about 3 or 4 years ago now, so it's an old-fashioned model as far as I'm concerned, but it is very much every nut, bolt, type that goes into a building. And what we found is that we were working with, it was a BREEAM-rated building, and the first thing that we got was a knock on the door saying, look, you're not producing enough waste. And that's, or rather, we don't believe the figures that you're coming up with. And one of the reasons is that once you have precise quantification, nothing can turn up to site that shouldn't be there in the first place. And when you do that, that's really practical. It actually doesn't matter at that stage whether you're using the most sustainable material or not. If you haven't even got there, if you're very basic, you're now coupling self-interest to waste. And that works because even though Chris said 3 to 5% is not a lot of clients think that's the end of the world, right? So what you want to do is get them to beat the line. So self-interest coupled with sustainability works. So waste-free is really good because it brings the price down. Digital markets ready and validated is really a little bit what Helen talked about. Know your supply chain, know exactly where everything's coming, parts, systems, you're data rich, you're standard compliant and incredibly precise. That's what you're looking for from the model. And anything less really doesn't cut it. So, hypergranular BIM accurately digitized buildings before they're built, providing many benefits. As we've already said, precise quantification. Optimized sequence for construction, so everybody knows what they're doing, and digital lifecycle management, so we know what to do with the building at the end of it. And all of this is powered by self-interest, because that's what we've found works best. I mean, it's nice to talk about being green, it's nice to talk about being sustainable, but the way that we find it really successful is if it's self-interest. If the building is costing less, if it's going up faster, if it's costing less to run, all of those things drive the agenda. They fit, they synchronize with what everybody wants. And if you've got that, you've got the whole audience, and that's what you want. And the others are hard sell by comparison. So, having said that, I'll try, hopefully my technology will work here, I'll try and show you a model. So, this is what people normally have. So that's what we normally have when we have drawings, 2D drawings, and what we like to try and do is take those 2D drawings.
I think I just heard a gasp.
It's
not here.
And here we look at the 2D drawing that's here underneath, and we have the 3D application here underneath. So I'm just going to try and move that around now. Let's just take that off. So I've just moved that drawing layer down, and I'm going to pop the rest of the building out. So what we have here is, you can see the old 2D sitting down here, but when we say every nut and bolt or every column, I do mean that. So we have information on every bit of the model that you want. So we'll tell you what a drain coupling is underneath there, or once we go into the building, you can see that this is down to every clip that holds an underfloor heating pipe down. So as we go into the building too, we can actually go into the levels. Let's have a look here. Okay, even if we're going for nuts and bolts, we'll be able to tell you what those nuts and bolts are. And therefore, really you can put any amount of information that you want in around these elements. And if you want to see where their supply chain comes from or what they're connected to, you can tap onto them, and you can have, with a bit of luck, hang on, we should get there. There we go. So you can get the information almost immediately from the model, and that's what you want to do. In the same way, you should be able to also ask the model who built it, who validated it, who designed it, how much did it cost, how much carbon was there embedded in it. So these are all the questions that we hope the models will help to answer. Just push that back down. I think I've frozen my model, which is unusual. I'm going to take it out. In fact, I'm actually going to take you into another model very quickly to show you end of life cycle, which is interesting. And quite often we do these buildings, we do them for community centres or where money is very poorly spent, or where you get the least amount of money to show what can be done at the tightest budget. So this was a community centre in Peckham, and if it can be done on the Old Kent Road for a very tight budget, can almost be done anywhere. So again, the level of detail is the same here. We can get down to the nuts and bolts. We can also look at how the building is put together. So the most optimum sequences. So it's just opening up here. So this really shows sequence 1, and then the next sequence 2, and so on. So you can really get into how the building's put together. And then if you need to, at the end of the project, at the end of its lifespan, this building was designed to be disassembled at the end of its life cycle. So you can pack it up and rebuild it somewhere else if you wanted to do that. Now, in order to know that, how you did it, every single screw is modeled. And so each one of these is digitized, so we know where every screw comes from, we know where every plate comes from, and we know which order we need to take this building apart, how to take this building apart if we want to in the future. And I'll finish this just with a little bit of supply chain, I think. Services quantity. I'm just going to change the top model here so you can see this. Sorry, this is a live exercise, but I hope you get there. So, the model also gives you a very precise list of everything you use in it. So, down to the most basic parts that nobody ever sees, and you can find them. You can simply ask the model, where are they? And hopefully, they'll say, I'm over here, this is where I am. So, once we are hypergranular, we can commodify a building. Once we can commodify a building, we can break it down into all its parts, constituent parts, and then we can trace everything. When you put that all on blockchain, it becomes incredibly secure for everybody involved. So, it becomes secure, it becomes valid, and becomes traceable, most importantly traceable. And once that happens, it becomes accountable, and I think that's where we need to see the future going. So build it first, virtually, get everybody on board, and then build it for real. And I think that's the way that we'll see the future go in construction. That's it for me.
This kind of project has been used in real life.
Oh yes, all of these are real. So perhaps what I should show you is this.
So all blockchain stuff have been used.
So the blockchain will be putting the first building on chain hopefully later this year. But let me see if I can show you something here. So that's the model view you just saw.
Yep.
Yeah. That's the real building that was built.
Oh, awesome.
Yeah. So I mean, if you look, it's pretty much verbatim. We even knew where the light was going to fall.
So I'm wondering, so is it using blockchain would increase the cost, or maybe?
No, I mean, I think that that's a great question, because blockchain has been high in gas, but now there's systems with almost zero gas. So we're really looking at zero gas solutions. In fact, we call this geometry as a service, which is gas. without the gas.
I see. Thank you so much.
No problem.
Okay, if there's no other immediate questions, I'm going to stand up and thank all the speakers.